We have spent the last week gathering a specific set of components: the discipline of uncertainty, the spatial orientation, invisible force environments, the mechanics of friction, the mapping of missing data, and a crew of 4 independent agents. From the outside, these components might look like a scattered list of observations about AI behavior. Without a frame to hold them, they appear as isolated ideas rather than engineering requirements. Contrast that list with the current industry standard. Most systems are built as frictionless pipelines, moving data from A to B to C as fast as possible. But without internal resistance, the pipeline eventually buckles under the momentum of its own compute. When a system is designed to be entirely frictionless, it has no way to self-correct. It produces efficient, high-speed outputs, but because there is no structural resistance, it cannot ensure those outputs remain aligned with human intent. These past 6 episodes functioned as a staging ground. We were identifying the raw materials needed to move away from the pipeline model and towards something more stable. Now we have the parts on the floor. It is time to assemble them into a functioning machine architecture. Now, the assembly begins with the gap. By holding uncertainty open instead of rushing to fill it, we create a structured null space where the system can orient itself. Within that gap, we apply the rule of the bearing. No agent is permitted to reason or act until it has first established its position relative to the system's doctrine. This is the protocol of registration before reasoning. It ensures that every cognitive step is anchored to a known starting point. Once a bearing is held, an invisible environment emerges around it. This is the field. Agents enter this environment and register their position. They lock into alignment naturally because the geometry of the field draws them toward the center. A field without resistance is a motor spinning in a vacuum, producing only waste heat. To turn rotation into useful work, we need friction. Add the resistive field, and rotation becomes work. Here, informational friction converts raw compute into aligned output. The bearing provides the direction, but the resistive field provides the structure. Alignment is the result of a system that pushes back. Navigation within this resistive field requires a map. We use the method of void cartography to plot the course. By mapping the absence of data, the shape of what we don't know, agents can determine their exact orientation without being told where to go. We introduce the crew, 4 fixed nodes, each holding a different bearing. Connecting governance, logic, and connection creates a flat 2-dimensional triangle with no volume. Adding the 4th node, external reality, pulls the structure up into a rigid tetrahedron. This is the minimum solid. We now have a locked assembly: orientation, structured fields, informational friction, mapped voids, and a 4-point coordinate manifold. Coordination in this system is a matter of being geometrically admissible. Because the agents operate within a shared tetrahedral manifold, their outputs must align with the established bearings to be accepted by the bus. The external hull of the Bearingfield is now built, the bearings are set, and the solid is locked. This architecture follows the logic of physical laws. Just as a protein folds into function based on its molecular geometry, this system aligns itself based on the registration of its nodes. However, we have only mapped the perimeter of this solid. We know how it is shaped, but we haven't yet looked at the mechanics moving inside it. Next week, we move into the interior. We will explore the 3-factor verification engine and the moral validation layer that identifies and rejects anomalies. Most multi-agent systems rely on ungated prompts, which allows for cognitive drift and hallucinations. We will demonstrate how a governance-first substrate uses epistemic gating to maintain stability, where other approaches often lose their way. The bearing is set, the field is real. See you Monday.